Alright folks, here's our first video for Algebra 2. This video is going to be about linear equations in slope-intercept form. Now before we get to slope-intercept form, we're going to take just a moment to review slope. Written here you'll see many different ways of representing slope. We'll often use the letter m to represent a slope, and we know that slope is the change in y over change in x, and we calculate change in y by saying y2 minus y1. We calculate change in x by saying x2 minus x1. We divide the change in y by the change in x. So let's take a look at an example. In this example, we will try to find the slope of a line between the points negative 4, 7 and 3, 1. And we will say, okay, m is equal to y2, we'll say is 1, minus y1, we'll say is 7, over x2, we'll say is 3, minus x1 we'll say is negative 4, so minus negative 4, and that's going to be negative 6 over, well that's going to be 3 plus 4, so that'll be negative 6 sevenths would be the slope of that line. Now please be very careful about what you choose to be your y2 and x2. They need to come from the same point. We notice looking right here the 3 and 1 both come from this second point. And likewise, we need to be careful that the y1 and the x1 come from the same point, just as the 7 and the negative 4 both come from the first point right here. If you screw that up, you're going to have a bad time. And I'll do one more quick example of this. So I haven't written out what we're doing here, but we are solving for the slope of the line between these 2 points. We'll say m is equal to y2 minus y1, so we'll say 7 minus negative 5 over x2 minus x1 is 17 minus 3, and that's going to be 12 fourteenths. And that reduces to 6 sevenths. So hopefully we're feeling like we're in decent shape on slope now. Now, this should probably look familiar, that an equation in slope-intercept form looks like y equals mx plus b. And we call it slope-intercept form because the two things it has are the slope and the y-intercept. And so we will look at how we're going to use an equation in slope-intercept form to create a graph. So let's start with a simple example. Y equals 3x minus 2. Now we can again identify, hey, 3 is the slope, which, remember, is 3 over 1, and the y-intercept is going to be negative 2. So I can go ahead and plot my y-intercept at 0, negative 2 right here, and my slope of 3 over 1 says change in y is 3 when change in x is 1, so I go up 1, 2, 3 over 1, 2, 1, 1, again up 1, 2, 3 over 1, and up again 1, 2, 3 over 1. And I can even go in the other direction. I can go down 1, 2, 3 over negative 1. And I plot a few points like this, and I can give myself a line. Now I'm having a lot of trouble drawing a straight line on this iPad, but you need to be using a ruler when you do this sort of thing for homework and make a neat line. So again, this was an example because we had a slope of 3 and a y-intercept of negative 2. And I'll go ahead and erase this one and give us one more practice problem with this. So here again I've got a slope of negative 2/3 and a y-intercept of 4. I'm always going to start with that y-intercept, so I'll plot my 0, 4 right there. And my slope is negative 2/3. That says change in y is negative 2 when the change in x is positive 3. So I go down 2 over 3, plot a point, and I can go down 2 more over 3 more, plot another point. Or I can go up 2 over negative 3 and get myself some points there, which I will connect with as straight a line as I can on here. And I'm sorry, I'm having a lot of trouble getting that to line up, but you know you need to use a ruler when you do this for homework. Alright. So now we know how to go from having an equation to having a graph. The next thing we're going to look at is, if I give you 2 points, how do we come up with the equation in slope-intercept form for that line that connects those 2 points? So I will consider the equation of the line connecting the point negative 3, 0 and the point 6, 6. Now whenever we're writing the equation for a line, we need to think to ourselves, what is the name of that form? I want to write an equation in slope-intercept form that tells me the two things I need to know are the slope and the y-intercept. And we'll start by calculating the slope. And we'll recall that the slope m is y2 minus y1, so that's 6 minus 0, over x2 minus x1, that's 6 minus negative 3, is going to be 6/9, is going to be 2/3. So I'm a long ways towards finding the equation because I've got half of what I need. I now have the slope, and I know that the line looks like y equals, well, m I know is 2/3 x, plus the b I still don't know, so I'm going to write it in there like that. Now this equation for the line should be true for any x and y that lie on the line. In particular, it should be true for these x and y that I know lie on the line. So I'm going to actually plug them in here and start working on solving for b. So I can say, let's see, y is 0 now, and that's 2/3 of x is negative 3 plus b. Okay, and then I can say this multiplication right here, the result of that is going to be negative 2. So I will then have that 0 equals negative 2 plus b, which means that 2 is equal to b. And now I can take this and put it right back here into this equation, and I will be done. My equation for my line is y equals 2/3 x plus 2. And if I really wanted to check, I could plug this point in for x and y and make sure that my equation is true. And I can plug this this point in for x and y and make sure that the equation is true. And I will just point out right here that we could actually use this if we had a graph to write the equation, because from that graph we could read off 2 points. If we had a graph for this line, we would be able to look at the graph and say, hey, here's one point, here's another point. Let me use those 2 points to do exactly what I did here and write the equation for the line. And we'll take a look at one more example of writing the equation for a line given 2 points on the line. So here's another example. Here are 2 points. We will write the slope-intercept form for a line connecting those 2 points. The last example worked out quite nicely, but here I've decided to take one that's a little bit messier. We're going to end up having to deal with some fractions. And we'll start by finding the slope. So we'll say, okay, m equals y2 minus y1, that's negative 3 minus 7, over x2 minus x1 is 4 minus negative 2. It's going to be negative 10 over 6 is negative 5/3. And I already know the equation for my line looks like y equals negative 5/3 x plus b. And now the last time it was clear which point I should pick because there was a 0 in one of them, and that makes it pretty easy to work with. For this one, there's no clearly indicated point. It doesn't really matter if I choose this one or this one, but I'm going to go ahead and work with the 4, negative 3. Plug that in here so that I can solve for my b value, my y-intercept. And so we'll say, okay, negative 3 goes in for y, so I'll get negative 3 equals negative 5/3 times 4 plus b. And now I'm going to have to deal with my fractions here. I know I'm going to have a denominator of 3, so I'm going to go ahead and write this left hand as negative 9/3, which is equal to 3. It's going to be equal to negative 20/3 plus b. And now I'm going to add 20/3 to each side, so I'll get that 11/3 is equal to b, which means that my final equation is y equals negative 5/3 x plus 11/3. And again, I could check to make sure that this is correct by plugging both of these in and making sure that I get true equations. That is something like 5 equals 5 would be a true equation. You get something like 5 equals 4, you know that's not true, you've made a mistake, go back and check your work. Now the final thing we're going to look at are horizontal and vertical lines. So we'll start by looking at this horizontal red line. And I want us to notice a few points on this horizontal line. For example, right here I've got a point 3, 2. Here's the point 4, 2, and the point 5, 2. and the point 2, 2. Every point on this horizontal line has the same y value. So we give that equation by saying, what is that y value? Well, we've got the y value of 2. That's the equation for this horizontal line, and every horizontal line will have an equation telling us what y equals. If you ever forget, just go through and identify a few points on there and notice the pattern. For all of them, y equals 2. And similarly for the vertical line, we can look and say, okay, here's a point -4, -5. Here's -4, 3. I'm sorry, this was -4, 5, and -4, 3, -4, 1. All of these have an x-coordinate of -4, so we say, hey, here's x equals -4 is the equation for that line. That's all I've got for the instruction, and on the next page I'm going to present you with a few problems that I'm going to ask you to prepare for class tomorrow. By completing these problems, that's how I'm going to give you a homework grade for tonight, so please make sure you complete these problems for class tomorrow. So for class tomorrow, please graph this line here given in slope-intercept form. Write the slope-intercept form equation for the line connecting 3, 0 and 6, -4. And finally, graph the line x equals -2 and the line y equals -3. Thank you, and I will see you in class tomorrow.